Hey everybody, this is going to be our last Unit 4 video. We're going to talk about the quadratic formula. Now, you've seen this in Algebra 1, okay, but we're going to look at some slightly more complex equations when using the quadratic formula to solve. A couple things you need to be reminded of, okay? Before we can use the quadratic formula, we have to make sure that our quadratic equation is in standard form and set equal to 0. Once you know your A, B, and C values, we're going to substitute those into the formula and simplify. So let's take a look here. There's a couple things we need to do before we can get started. We need to move everything to one side. Make sure it's set equal to 0. And then we can identify our A, B, and C values. So -2 will be A, -1 will be B, and then C will be the positive 15 here. So we're going to substitute those into our quadratic formula now. Now remember, the quadratic formula is x equals because we are finding the solutions, the x values, that make this equation true. So our formula is -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Notice the entire right side has a fraction bar with the 2a on the bottom. So now we're going to simplify, okay? Under my square root here, I'm going to get 1 plus 120. So I'm going to have 121 under my square root. And then in the denominator, I have a -4. Okay, we know the square root of 121 is really just 11. So this becomes 1 plus or minus 11 over -4. Now, at this point, we do not want to leave our answer written like this because we can simplify further. The plus or minus means that there's really two calculations to make here. Okay, the first calculation is 1 plus 11 divided by -4. The second calculation is 1 minus 11 divided by -4. So for the top one, we get 12 over -4, which is -3. For the second, we have a -10 over -4, which reduces to positive 5/2. So we have two solutions. We're going to write it as a solution set. X equals -3 and 5/2. So those are the two x values that make that equation that we started with true. We'll take one more example here. Okay, again, we have to get everything to one side first. So I'm going to move the 10x over so that this becomes 8x squared minus 10x equal to 0. Now, we're missing the c value here. So if it helps you, you might want to add a plus 0 at the end so that you remember that that is your actual c value. So 8 is a, -10 is b, and 0 is c. So we're going to go ahead and plug that into our quadratic formula again. X equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So now we're going back through and we are simplifying. So we end up with a positive 10 plus or minus. And then if we look at the square root here, this whole thing is going to become 0 because -4 times 8 times 0 is just 0. So under the square root, we just have the 100 that comes from that -10 squared. In our denominator, we have a 16. So now we can take the square root. 10 plus or minus 10 over 16. Okay, and then here we can split that into our two calculations again. Our first solution is going to be given to us from 10 plus 10 divided by 16. And the second one will come from 10 minus 10 divided by 16. Okay, so here, this is going to reduce to 5/4. And here we just end up with 0. So let's write it as a solution set, and we're done. Now, something to be on the lookout for. You now know how to break down square roots. So if we end up with something that's not a perfect square under a square root, you would break it down like we have previously. And it's possible that it could be a negative number. So it is possible. You can end up with imaginary numbers as part of your solution. Let me know if you guys have any questions, and have a wonderful day.